Today we're going to talk about Lesson 3-2, solving equations with tables and graphs. And what you remember from the other day is the fact that we studied equations, we put it on our calculator, the equations, we looked at the tables and graphs. So this is kind of a repeat of what we did yesterday. Tables and graphs lead to exact or approximate solutions to equations. Our graphs is where we normally get the approximate. Because of our calculators, we don't kind of get a rounded off when we look at graphs. But on the tables, you could get all the way down to the hundreds, the thousands, the 100,000s, whatever you wanted to get to. We normally only go to 2 decimal places, so that's probably all you need to go to. And you might want to write that down. Mr. Johnson looks for 2 decimal places. And what I want you to remember is if we're going to go to that extreme of getting 2 decimal places, what you do on your table is you hit second function table set, and instead of having your table go up by ones, you go up by 0.01 after you kind of found out where you're located at. And what I mean by after you found out where you're located at, the difference is you want to see where you're going to start your table at, okay? You might not start it until the 100th place. So a lot of times what you can do is you can get your graph first and then find out where you need to start your table at. Otherwise, you're going to do a lot of scrolling, which is not something you really want to do, okay? Especially if your answers clear up into the thousands or something like that, okay? So it says consider an equation that contains one variable, such as 2 plus x equals 6. We all know the answer is 4. A solution to the equation is a value of the variable that makes the equation true. So for 2 plus x equals 6, 4 is a solution because 2 plus 4 equals 6. Now, what you need to understand is on a graph or on a table, what you can do is you can put the left side of your equation as your y1. You put your right side of your equation as your y2. And what's going to happen is these two things are going to intersect. Where they intersect gives you your solution. Okay? That's the glory of these tables or graphs. So example 1 says solve 11 equals 4x plus 3 using a table. Okay, so I'm going to let this be my y1, the left-hand side. I'm going to let this be my y2. That's my right-hand side. So we just want to see where those two things are equal to each other. So I hit y equals, and I put in 11, and I put in 4x plus 3. Now, I'm going to look at the table because that's what they wanted us to look at. So I'm going to hit second function graph. And if you look here, when x is 7, y1 is 31. When x is 8, y2 is 35. So it starts to go up here. So I want to go back down. And I'm just trying to match these two things up. 1135, 1131. If you look here, when x is 7, y is 31. When x is 2, y1's 11, y2's 11. So that's where they intersect at, right here, at 2 when x equals 2. So my answer to example 1 is x equals 2. Now, can we check that? Yes, we can check that. We can put 2 back in here for x. So 4 times 2 plus 3. Well, 4 times 2 is 8 plus 3 is 11. Does 11 match 11? You bet your bottom dollar. So we just showed you how to solve this equation using a table. Okay? Get familiar with these calculators. Example 2 says, solve the same problem using a graph. So all I have to do is go back here. And what I need to do is make sure that my window is big enough, and if I hit second function zoom, sorry, not second function, zoom standard, okay? Notice how the first line graphed. We couldn't see that second line, so what I have to do is make it bigger. Well, why couldn't I see this? Actually, I couldn't see the first line. The first line is at 11. Okay, this is my 4x plus 3 line. Okay? Why couldn't I see it at 11? Well, we only go up to 10, right? So my window has to be bigger. So I got to change my Y max to be over 11, so I'm just going to say 15. And I'm going to hit graph. Now I can see that first line because it graphed at 11. There's my second line, and you're going to have to change that window quite often. But if you scroll up here, sometimes on the graph it doesn't give you the exact, especially on these calculators. Okay? So if I scroll over here to see right where they intercept, normally if you're going to use the graph, you're going to have to say about or approximate. So, and you can see that you're pretty darn close to 2. If I were to be right on it, notice how it goes 2.1 if I get to the right, and then it says 1.9 if I go to the left. Sometimes if you hit this trace button, it will give you a little bit better reading, but it's not always the case. See, I'm still at 1.9. Okay, yeah. So you could say approximately 1.9. And what happens is you're not getting a true reading using your graph. So approximately 1.9, close works when using graph. Okay? Now, Mr. Johnson loves using tables. Okay? I don't know, probably because I just love exact answers, okay? But if you like using the graph, please go ahead and use it, okay? What I found out a lot of times is I always had to change that window a lot. Example 3 says, Khalid lives in Alaska where there is no sales tax. He bought 3 tacos with a $5 bill and received 77 cents in change. Define a variable and represent a relationship with the equation. So T is going to be price of tacos, because we don't know actually how much a taco costs. And it should just be price of taco, because it's going to be 1 taco. So what did he start with? Well, he had $5, right? So there's my starting point. So 5. And then he bought 3 tacos. Do you add or subtract when you're buying tacos? Well, you subtract. He subtracted 3 tacos from his $5 bill. And he ended up with 77 cents in change. Everybody see how Mr. Johnson got that equation? Started with $5. He subtracted 3 tacos from it. He ended up with 77 cents in change. So, Y1, Y2. And that's going to give us how much those tacos are. So let's go to our calculator. Y equals. And a lot of times in algebra, what you're going to find out is your standard viewing window is normally going to be enough to solve most of these equations, okay? If you notice, our Y value only has to go up to, or we only have to go up to 77 cents, correct? So I'm going to show you, table-wise, okay, per se, on what it's going to look like if you go to your table. So if you look here, we want it to get close to 77 cents. And if you notice, if 1 goes in there, you get out 2. So it looks like our tacos are going to be less than $1 a piece, probably. So if I go to my table setup, I'm going to go by 0.01 just simply because we're talking about money here. Okay. And that's fine. Okay. But if you look here, and I should have started my table at $1. Okay. Notice how you're going to have to look through this a whole bunch. It started at 6 cents. I don't want that. So I'm going to start at $1 right up here because I think my taco is going to be around $1. Okay. So if you look here, yeah, we're close. It's at $2 now, right? So we need to go higher. So let's say $1.50. I'm going to start at $1.50. Second function graph. My too high. Got up too high, didn't I? So I'm going to keep scrolling until these equal 77 cents. That's how easy this is. Okay? And if you scroll up to about 1.41, okay, that is going to be your price of your tacos. Okay? If you had $5 and you subtracted 3 tacos at $1.41, okay, it's going to give you $1.41 is the price of a taco. Okay? Now, could you put this in here and see if it worked? Sure. My guess is 3 times 1.41. Three times 1.41 12. Notice Mr. Johnson just went ahead and did it by his hand. $4.23 equals, well, $5 minus $4.23 is 77 cents, right? So it worked out. You can always check your work. Moving on. Sorry. Todd has $250 in his savings account. If he has a job that pays $11 per hour, how many working hours will it take for him to have enough money to buy a $481 surfboard? Okay? So my variable X is going to be number of hours worked, right? And what happens is he started out with so much money. How much money did he start out with? $250. Okay? Equals, sorry, not equals. He started with $250 and then he gains money. How much money does he gain? Well, he gets paid $11 per hour. So does he gain that? Yes. That's my addition. $11 per hour. Do we know how many hours he worked? No, that's my variable. That's my X. Has to equal, well, he's got to get all the way up to 481 if he wants to buy that lovely surfboard. Okay? So, make this my Y1, make this my Y2. Now, if you look at this, my Y max has to be greater than 480. Otherwise, I'm not going to be able to see that line. So you might as well change the table while you're in here. So let's go to Y equals, clear that out, 250 plus 11x. And we want it to equal 481. Now, like I said, you might as well just go straight to your window because this Y max is going to have to be at least 500. And I'm just going to make my scale go by 50s. Okay? Obviously, my Y min could start at 0. Okay? Actually, you could probably start at 200, right? We know we're going to be up there. Okay? My guess is that my X max is probably going to be bigger. So I'm just going to try 25, see if that works. So there's a line. There they intersect. I just got lucky. If I would have left it at 10, I would have had to change my X max. So essentially, I just basically got lucky. But if I scroll up here, I can see where those two things intersect, right? And if I go down here, it's going to tell me my X is approximately 20.9 hours. So you could say Todd has to work about 21 hours because his boss probably ain't going to let him work 20.9 hours. So in order to buy that surfboard, Todd is going to have to work 21 hours. That's all I have for you today. Please enjoy. We'll see you tomorrow.